Welcome to the Electrical and Electronic Engineering Lecture Series. Your anchor person is Professor Michael C. Ndinechi. Our topic today remains Engineering Lecture Series, Self-Test Part 2. We want to continue with our self-test exercise so that you will test yourself and see how well you have understood the engineering lecture series. So we will guide you through, which we started yesterday, and started by saying a group of 8 bits is known as what? We said as a byte, which is C. The number of bits used to convey data in a computer or microprocessor is known as its word length. So answer A, we ask what is the 2's complement of minus 15? We said it is B1001, and we've talked of how you do that by getting equivalent of 15, which is 1111. So you append a 0, which, because of the negative sign, you complement it, it will give you 10000. You add 1 to get the 2's complement, and it makes it 10001, which makes B the answer. Now, say a byte has how many bits? We agreed it is 8 bits. So, which makes answer D. Also, we said the term fixed point indicates the position where the power of the base 2 weighting changes from positive to negative. Is it true or false? I agree that it is true, because after 2 raised to power 0, if you are going to the right, you now cross the fixed point, and what you have now is negative 2 raised to power minus 1. Then 6, what is the full meaning of the acronym ASCII? We said, is it Associated System Code for Information Interchange? No. Is it American System Computer Information Institution? No. Is it American Standard Code for Information Interchange? Yes. Associated Standard Code for Information Interchange? No. So the answer is C. Then we quickly look at this. Say the register that holds the address for a stack is known as the stack pointer. So our answer is B. Then top-down design approach in flow charting, we say that is known as structured design. Then say the first step in computer system design is what? We agree that it is problem identification, which we say the answer is A. So then say 10. One of these is a high-level programming language. Can you guess which one? Is Microsoft Word a programming language? No, it's an application software. Is C++ a high-level programming language? The answer is B. Excel is an application software, and MS-DOS is an operating system, even though no longer in use. So say our answer is B, C++. Then 11, the process of tracking down the execution errors and correcting them in a program is referred to as compiling, which is not. execution, which is not, debugging, which is the answer or translation. So you can look back in our lectures on computer module 014, module 7, and module 6, and there you will get what each of these terms do or represent. That is compiling, execution, debugging, and translation. So we now say convert this number B8F16 to binary. We feel it is very easy to do. First, we say that when you are given a number in base 16 to convert to binary, you start from the least significant figure, which is the one to your right. Now, F is 1111 in base 2. Remember, in hexadecimal, F represents 15. So if you convert 15 to binary number, you will have 1111. So 8 in base 2 is 1000, and B in base 2 is 1011. You just list them like that, and it gives you the binary equivalent. If, on the other hand, you want to convert binary equivalent to base 16, it's as easy as ABC, whereby you just put the binary number and group it starting from the least significant figure, 4 bits by 4 bits. So if you get the first 4 bits, you'll find its equivalent in base 16. The second 4 bits, its equivalent in base 16. The third 4 bits, its equivalent in base 16. So it gives you what you want as easy as that. So we say that here our answer is A, because if you look at A, the first 4 bits is 1111, which represents 15, which is represented by letter F in hexadecimal. The second 4 bits is 1000, which represents 8 in binary. And the last 4 bits is 1011, which represents a B. So that gives the answer. So now, which of these statements is false about a general purpose computer? 1, say the capacity of the hard disk determines the amount of information that can be stored. Is that true or false? Of course, it is true, because if your capacity hard disk is not enough to store what you want, then your computer will be limited. 2, say the RAM size determines the range of software that the computer can accommodate or run. Say this assertion is true, because the RAM, if the size of the software is bigger than the size of the RAM, your system will not be able to run it. Then C, the speed expressed as a function of frequency in megahertz determines how fast the computer can execute the instructions or data fed to it. And this is also true, because the speed, which we call the clock speed, determines the number of operations that your system or your computer can operate in a second, which it calls millions of instructions per second or millions of operations per second. So C is correct. Now the ROM cannot retain information after power off. We know that it is false, that on power off, the ROM continues to, remain active, and that is why we say that it is not volatile. So if we continue, so the answer is D. Now, which of these is not an input device to the computer? Keyboard, we know keyboard is an input. Mouse, we know mouse is an input. Printer, we know that printer is an output device. And flash disk also is an input, and it can also serve as an output. So our answer is C. Now 15, which of these is an output device to the computer? Monitor, keyboard, joystick, OCR, that is optical character recognition. So we see that our answer is, of course, A. Monitor is an output device to the computer. Now, which of these is not a building block of a central processing unit, CPU? Say 1, or A, memory unit, B, keyboard, C, control unit, and D, arithmetic logic unit. If you recall, when we showed the building block of the central processing unit, we have our memory unit, our control unit, and our arithmetic logic unit, ALU. So you see that keyboard is not a part of the building block, because keyboard is, an input device to the CPU. So our answer is B. Keyboard is not part of the building block of a central processing unit. Now, 17, for a computer to work optimally, 3 things must be present. So which of these is not the 3 thing, or one of the 3 things? We say that it has hardware, which we illustrated using the car. Say that the physical car must be there. So for the computer, the physical computer, which is the hardware, must be there. The software, which we said is, analogous to the petrol, or if it is electric car, the electricity that drives it. Then the peopleware, which is the people that mounts it, even if it is remotely. So what is not, must that it will be there for a computer to work optimally is the I/O device. So our answer becomes C. So we continue. So computer registers are used to A, store data or instructions that are needed immediately or frequently. That we agree to. Process data movement in computers. Consider that. Examine incoming instructions to determine how they should be processed. And finally, control movement of data to and from the CPU. Of course, the registers does one thing, and that is store data or instructions that are needed immediately or frequently. As we go on, when we did our addressing techniques, you see how you move information, either instructions or data, to the registers, and from there you do your computation or your logic, then supply the answer. So 19 says, which of these is a secondary memory device? If you recall, when we did memory devices, we talked of the primary storage system or primary memory, which we call the ROM and the RAM. So, and we said firmware, which is built where the software is, the hardware that is manufactured with the software there, which may come in form of ROM or RAM. And the only secondary memory device here is the CD-ROM, which is the compact disc read-only memory. So our answer is D. So 20, we say a computer that uses a word length of 16 bits can address how many locations? Now, we need to do some small computation. Word length is the number of bits that you can use to, pass information in a computer. So if you now have 16 bits of it, then you can see what it will give, and that will be equivalent to 65,536 locations. So you can look it up in our model 014, where we showed computation of how that is being done. So 21, which of these statements is not true about the computer memory? A, it holds the data and instructions of the program which have been fed into the CPU via the input unit. 2, it also holds the permanently stored program known as the operating system program. 3, the memory values are usually expressed in megabytes or gigabytes. And D, you say all memories are volatile. Which one do you agree with? We do not agree that all memories are volatile, because we said only RAM is volatile. ROMs are not volatile, and we agree that the ROM has the CMOS battery that supports it for a very long time. That does not mean that if you keep your computer permanently forever without plugging it, that the CMOS battery will not one day go down. But it takes a long time. So we say that memories built on as ROM are not volatile. They stay for a long time because they are being powered by CMOS battery. And in one of our lectures where we looked at the classes of gates or ICs, we saw that the CMOS technologies, are used where, much power is not needed. So all the terms here are describing computer memory, except the which says that all memories are volatile. All memories are not volatile. ROMs are not volatile. So a software that does special operations like data backup is called what? We have utility software, assembler software, firmware, and opcode. Of course, opcode is off. Opcode is not a software, it's the operations code. Firmware, we said, is a hardware that is being programmed to perform specific tasks. Then assembler software, of course, is used for, another thing, while the utility software is the one that are used for data backup, virus cleaning, and so on and so forth. So, 23, assembly language software is also known as what? In the past, in our lectures, we made it clear that assembly language software is also known as machine languages, which makes the answer C. It's not a compiler, it's not a source code, and it's not a natural language. So assembly language software is also known as machine language. So which of these statements is not true? A, a program is any list of instructions or routines set out in logical order to solve a particular problem. B, software is the general term used to denote all forms of program associated with computing system. C, computer hardware is used to describe input-output chips only. And D, the term software includes not only programs, but any documentation associated with the computer, such as manuals. And, we agreed to A, we agreed to B. C says that computer hardware is used to describe input-output chips. No, computer hardware is also used to describe the microprocessor in the computer and other hardware components of the computer, and not only input-output chips. So see, C becomes the answer. It is not a fact. It is not true. So now, so programs written by experienced programmers that enable the user to quickly get some work done are called what? High-level language? Of course, no. Applications software? Yes. Word processor? Word processor is just, a component of application software. Likewise, desktop publishing. So our answer becomes B, because the programs written to help you do your work are called applications. Then 28, the instructions that as they are entered on the keyboard are known as 1, interpreters, B, text editors, C, operating systems, D, input-output tools. Of course, we know that they are called the interpreters. When you are keying in your instructions, they are interpreting it the way the machine will understand it. So they are called interpreters. 29, which one is not a function of an operating system software? In other words, what does your OS do? Say booting, object linking and embedding, I/O control, user control. So we know that when you start your computer, you say that you are booting it. What is happening is that the operating system is trying to organize what you are doing. The OLE, that is object linking and embedding, is not a function of the operating system. It is, that ability of some programs like Visual Basic to help you design a user interface. So, of course, your operating system controls your input-output devices or peripheral devices like your keyboard, like setting your output to go to the monitor or to the printer. And of course, if you have a multi-user system, the operating system like Linux and helps you to operate and control users. So our answer there becomes B. The operating system doesn't do object linking and embedding, OLE. So a computer professional is one who has become proficient in all but one of the following: system analysis, of course. A computer professional who is proficient in system analysis, we say, is a systems analyst. Again, a computer proficient person who specializes in programming, we say, is a programmer. And of course, somebody that just uses computer is not a professional, because everybody now can use computer or even digital systems that are more sophisticated than the computer. So it's clear that just somebody that uses computer is not a professional, but somebody that makes use of that repairs or maintains computer system, we call the systems engineer. So you see that C, which is system usage, is not a professional, and you don't have to be proficient in any special area of the computer to use it. So 31, which of these is correct about a systems analyst? Say A, which of these is correct about a systems analyst? A, must be a person who can mix easily with people and communicate effectively. Good, because for him to analyze, he must be able to do that. B, develop the codes that make the hardware perform the required function. That is the work of a programmer. C, must have the ability to reason logically and to pay very careful attention to details. Even though, but that is not his core mandate. D, keep a log recording of the utilization of the machine time and report any issues resulting in the loss of machine time. Of course, that should be the work of the operator. So you see, A, which is must be a person who can mix easily with people and communicate effectively for the person to be a good systems analyst. Now, so what is the equivalent of 0.1101 in base 2 in decimal? We say, could it be 0.9375 in base 10? Could it be 0.0625 in base 10? Could it be 0.8125 in base 10? Or could it be 0.0525 in base 10? We say that the answer is C. Now, how did we get the answer to be C? We have looked at when we say fixed point, that immediately you cross the point to the right, you are moving from positive to negative. So here we have to the right 0.1101. So the first one there, the first one on the left is 1 times 2 raised to power minus 1 plus 1 times 2 raised to power minus 2 plus, of course, 0 times something goes Then the other one will now be 1 times 2 raised to power minus 4. So if you do that, it becomes 2 raised to power minus 1 will give you 1 over 2. Likewise, if you do that and sum them, you see that it will give you 0.8125. That becomes your answer. Now, it says converting 18 to binary gives you what? Normally, we say you divide by 2 and take the carries, and at the end, you start from bottom and line up the remainders. It will give you the equivalent of that. So here, the answer becomes B, which is 10010. So a sequence of 4 bits is known as what? So byte? Of course, no. We say that byte is a sequence of 8 bits. And word length, we say it doesn't really matter. Word length can be any number of bits, provided it is what is used to represent, a word or in the computer. Then C, neighbor. Of course, we say that neighbor is any group of 4 binary bits you call a neighbor. Then D, bit, of course, bit could be 0, it could be 1. Any binary number 0 or 1 is known as bit. So our answer becomes C. Then 35 say the address location BFFF in base 16 corresponds to decimal equivalent of what? Say 49151 in base 10, 45056 in base 10, 4096 in base 10, and 1024 in base 10. So, how to find it? You say this will be F is 15 in base 16. So, say 15, you start from the least significant figure, the least significant bit, which is the one to your right. That is the first F to your right there. So that F is 15. So its decimal equivalent is 15 times 16 raised to power 0. The next one is 15 times 16 raised to power 1. The next one is 15 times 16 raised to power 2. And B is what? 11. So the B represents 11 times 16 raised to power 3. So if you expand that and add, you'll see that it will give you 49151 in base 10. So that becomes your answer. Now, 36, so which of these 4 neighbors is not used in the BCD code? What do we mean by BCD? Binary coded decimal. So, and we say that this BCD code do not make use of 6 combinations of binary number. So, which one is not used in BCD code here? For your information, in BCD code, A in base 16, B in base 16, D, C, E, and F are not used. So if you look at the bits here, A to D, you will now see one that falls there. A is what? Is 9, equivalent in binary. B is just 1, which is equivalent 1 in binary. C is 111, which is 7, while D is 1110, which is E. So the answer becomes D, because just what you have said, A to F in decimal, which is 10 to 15 in decimal, A to F in hexadecimal, and its equivalent in binary are not used in BCD codes. The reason is that the system will not know when it is just a code or when it is representing a number, so it doesn't use it. Now, so what is the ones complement of the number minus 9 in base 10? Now, where do we find the complement of a number? We say that in the binary sign and magnitude number system, the computer finds it difficult to do addition when one of the numbers is a negative number. So to handle that negative number and get the correct sign number at the end of each operation, it has to find the 2's complement of that negative number to be able to, manipulate the sign. So, for instance, here it says minus 9. So, what is binary number 9? We know that it is 1001. Because of the minus sign, it appends what? It appends a 0, because it uses 0 for negative numbers. So that's 1001. The most significant bit it will append to there becomes a 0 because of the minus sign. And we now say to find the ones complement of a number, you change all ones to zeros and all zeros to ones. When you do that, you now see that that most significant bit 0 that is representing the minus sign becomes a 1. Then the other ones, because it's 1001, we now change to 0110. So your correct answer will now be B, which is 10110. Now, say for you to go further to get the 2's complement, we say that you will just add 1 to the least significant bit of your 1's complement. So if 1's complement of minus 9 is 10110, then the 2's complement will be what? Of course, 10111. That gives our answer A, because it's that 1's complement that we just added a 1, it becomes 10110. Now, of course, say what is the 2's complement of plus 15? Can you guess? Of course, 15 in binary is 1111. Now, for you to do the 2's complement, because it is a positive number, so you have 1. And that 1 111, because it's a positive number, you don't do anything to it. It remains 11 because you only find 2's complement of negative numbers. So it gives you that. Do you agree? So we say this is a number, a string of binary digits. We say convert it to hexadecimal. What do you think your answer will be? As agreed before, when you have a string of binary numbers which you want to convert to hexadecimal, you start from your right, the least significant figure, and group them in 4 bits. If you group them in 4 bits, you'll find the hex equivalent of each of them and put them together, it gives you the answer. For instance, in this one, if you start from the least significant bits, that is your right side, what you count 4 digits from the list, you give 1100. So that is the first grouping. So 0011 means 3 in hexadecimal. You put 3. The next 4, which is 1111, which is equal to 15, which is F. So you put F. The next one, 4 bits, which is 1000, which is equivalent to 8. So you put your 8. And the last 4 bits, which is 1011, which is equivalent to 11, which is B, gives you that. So you see that automatically our answer becomes a C, which is B8F3 in base 16. So any number that is given to you in base 2 to convert to base 16, you just group them in 4 bits and put their hexadecimal equivalent, and it gives you the answer. Which statement is incorrect? So every memory is constructed from a collection of memory cells, with each having its own unique name known as its address. That should be correct, because every memory is, a group of cells having its own address. Each of the memory cells contains a piece of data referred to as its content. Yes. Every memory cell holds one piece of data at a time. Each memory operates on data structure. The answer is D. Memories don't operate on data structure. Rather, the CPU does. Now, during the read operation, remember your CPU will either read or write. So say during the read operation, what happens? The contents of the memory cell remain unaltered. B, the contents of the memory cell is altered. C, the contents of the memory cell is deleted. And D, the contents of the memory is shifted. Say our answer is A, that during the memory read operation, the content of the memory cell remain unaltered. For instance, when you read the value that is in memory location X, it will read it. That value still remains there until you write something to overwrite it, else it remains there. So if you have a content of a memory location and you have 10 there, if you read that 10, and take it, 10 still remains there. It will remain there until you overwrite that 10 by writing something into that memory location. Else, that 10 there will remain unaltered. That is how memory locations work. So now we said if we have a memory described as a 32 by 4 memory system, what do we really mean? Does it mean that the word length is 32 bits? Does it mean that the word length is 4 bits? Does it mean that the word length is 128 bits? That is, does it mean that it's 32 times 4, 128? Or does it mean that the word length is 8 bits? Remember what we said word length is. That word length is the number of bits that is used to represent information in any computer system. You call it its word bit. Now, if you have a memory specified as 32 by 4, it means that that memory has 32 locations, and each location contains 4 bits, meaning that 4 bits is the word length of that memory system. At times you see, 64 by 8 and all those things. What it means is that this memory has this number of locations, and each of the location will contain this number of bits. And that number of bits become the word length that is used to convey information in that memory location. So, the memory store program concept was conceived by who? We say Charles Babbage, von Neumann, Steve Jobs, Bill Gates. I think this is as easy as we know who Bill Gates is. He's associated with Windows. We know Steve Jobs associated with Apple computers. We know Charles Babbage, the man that discovered the differential engine, which is those days called the father of modern computers, while von Neumann is the architect of stored program concept. Stored program concept was developed by this man and his team to, instead of feeding the computer always what to work with, you move the thing and store in the computer so that the computer takes the information in it from a space where it is stored in the computer and operate, thereby making the computer faster. But if you remember in our lectures, we say that, yeah, for Newman's architecture or this concept was very good, but that is not really the reason now why computers are very fast. Computers are very fast now because of the development in the MEMS technology, micro electromechanical systems technology. That is why computers are very fast now. But we give the credit to von Neumann for coming up with that stored program concept. So our answer is B, von Neumann. So say, what are the advantages of stored program concept? And what amongst these sentences or statements is not an advantage? So one, they use a single general purpose processors. Two, they use stored programs. Three, they process instructions sequentially. 4, there is no physical separation between instructions and data. That is D. So our answer is D, because it's a stored program concept. So they use one general purpose processor because the program is stored in that processor. B, they use stored programs, yes, because the concept is to store program. C, they process instructions sequentially. So when they are stored, it does one before the other, one before the other. So, and D, there is no physical separation between instructions and data. That became a very big disadvantage, because if the system sees data as instruction, then it will misfire by using the wrong data to perform the wrong instruction. So because two of them are put together, it becomes a problem. So we say that it has all these other advantages, but not having physical separation between instructions and data makes the thing, not to be really what it's supposed to be. It can make the system to misfire when it takes, data as instruction, or when it takes instructions as data. So now the other one is the main memory interfaces with the CPU via any of these buses except one. Which one? When we did the memory architecture, we saw that every memory chip is connected to the CPU through data bus or data lines, address lines, and control lines. But there is nothing like command lines in the CPU memory interface architecture. So our answer is C. The main memory interfaces with the CPU via any of these buses except command lines, because it is not known to the architecture. So the disadvantages of stored program concepts include all but one of these. One, the computer needs access to 2 or more registers concurrently to add 2 or more numbers. Of course, yes, it's a disadvantage. B, disastrous consequences could result from the system trying to obey or use data as instructions, just what we said, that it is a disadvantage. And C, they can alternate between instructions and execution cycles. Because D, there was no distinction between data and instructions. That becomes an issue. But you see, it is a disadvantage. The only one that is not advantage is C, because they can alternate between instructions and execution cycles.